Hey folks, in the last episode I did interview Franco Patano and we end up the episode with a very interesting question about which language to use because now you know that you can develop ETL using Python or SQL and maybe Franco will enlighten us regarding which technology to choose.
It's the unfortunate answer. It depends. It depends on a lot of things. But just to kind of give a little bit of the why of the what on Databricks, you can do data processing all kinds of ways. Originally, like a lot of people think, oh, I have to know Scala or I need to know Scala Spark. That was true like 10 years ago. It's no longer the case. I think I said before that it's about 50-50 Python and SQL, total aggregate executions on Databricks. So most of the world is using Python and SQL. And you can see this on any popular programming charts. Python and SQL are like the top two. And it's like that throughout the world. And so people always ask, like, well, I have data engineering is typically done in Python. Modern data engineering, you have the data engineering from like 10 years ago where it was Scala Spark or Hadoop MapReduce type of stuff. And I would say the spiritual successor to those data engineers is kind of like Python or PySpark. And kind of about 5 years ago, you saw this rise of the Pythonic distributed data engineer, and Spark kind of doing Python on Spark became more prevalent, I would say, over the past 5 years. And originally, I think I said previously, SQL on Spark was just a query language. Before Delta was introduced, I don't think you could do DML in Spark SQL. I don't think it was supported. 99% sure, it could be wrong. But there was no such thing as doing, insert into or merge into in SQL because you wrote data with a data frame back then. Then when Delta came out, and all of a sudden we could do DML on a data lake with transactions. The whole thing was in data warehousing and SQL languages, you expected some type of isolation. In order to do data warehousing, you have to have ACID compliance, atomic, consistent, isolated, and durable. So glad I remembered those words. I'm pretty sure that's what it stands for. There was no way to do that on a data lake before Delta and then Iceberg and then all the rest. There was no way to do that. You couldn't do it. You couldn't do typical SQL stuff. And then Delta brought the DML to the data lake. And then kind of all the other data lake formats followed suit. So now all of a sudden people introduced the language, the syntax in SQL and Spark SQL to do insert into, merge into, and update. I think those commands came with Delta around 2019. And so now you could do DML. Spark SQL didn't support, at the time, it didn't support like the long tail of warehousing features that the industry took 20 years to build from like the 1980s to the 2000s. And what we've spent at Databricks now is the past 5 years is building all of that stuff that you would expect out of a warehouse. And we talked about the last kind of group of features that we're working on now, transactions, tables, scripting. It's all kind of rolling out right now. So now, and then, this year we've been working with Lakeflow, which used to be called Delta Pipelines back in the day when it originally came out. It was originally Pipelines, and then it was then it was Delta Live Tables, and then it was, what did we change it to? Delta Live Tables. Then it was we wanted, I think, for a brief moment in time, wanted to call it just DLT, and then we rebranded into Lakeflow Declarative Pipelines, and now it's Spark Declarative Pipeline. Like, holy moly! That whole paradigm kind of is a completely different way. I call this the future. I had talked, I think Josue and I did a chat earlier this year when I said, this is the future, like declaratively building data pipelines is the future. Not everybody's doing it, right? It's super minimal that people are, but it's like the newest branch of data engineering. And like, why? Like, what's the big difference? It's an unfortunate story. Very long story short, SQL, by default, is a declarative language. The programmatic extensions that vendors built on top of SQL over the past 20, 30 years, like PL SQL, T SQL, I don't know what Teradata calls it, I think it's BTEC, something along those lines. They're all proprietary programmatic extensions to the SQL, to the declarative SQL language to make SQL imperative, meaning I have to tell you exactly where my data is, what I'm going to do to it, and where I'm going to put it. And it was like, for anyone paying attention, it was like, well, what are you doing? Why are we treating a declarative language imperative? It actually, with set processing that SQL is, it creates a ton of issues. Like, do you know what cursors are? Birthed this whole thing called cursors, where in a set, you have to figure out how to iterate it row by row. Anyone who knows anything about how set theory works, no, it's not what you do. Why are we doing that? That's crazy. What are we calling it now? Declarative pipelines? What declarative pipelines does is it brings declarative back to SQL and also to Python. Python, we're just going to let that sit there for a second. DLT has Python. If you're a Python data engineer, you should definitely leverage declarative pipelines. It makes a whole lot more sense to somebody coming from Python for sure, because Python is an imperative language by default. You have to tell it what to do. And when you're bringing declarative stuff and making Python simpler, Python people love DLT or declarative pipeline. It makes your code testable. It makes sense. It makes it easier. The SQL people, on the other hand, are like, what are you doing? Because you're turning around this concept on its head twice, where we went from declarative to imperative to declarative. We're making the imperative part of the declarative SQL declarative again. And for a lot of folks, this is mental gymnastics that's very hard to reason about. So I think that's like the big gap that we're seeing now is you can do ETL on Databricks with straight old-fashioned Python. You can plug it into jobs. You can do SQL on the serverless SQL warehouse, or you can do on generic compute, or you can do it on declarative pipelines. And the API just differs a little slightly to drive people insane. And then you kind of have like automated tooling now that's coming out. You have Lakeflow Designer and kind of like GUI based things. And it's like, well, what am I supposed to do? You have a new customer coming to Databricks, and like a lot of our SAs are kind of helping these customers out, and they're like, well, which do I choose? And this, in part, I think is a lot of the complexity with Databricks. It's the choice. We really have to choose. But why did we do this? Why are all these teams kind of internally at Databricks creating products that kind of overlap? They really overlap now, like DLT and some of the store procedures. Like, well, do I use a store procedure or do I use declarative pipelines to build my thing? And this is like one of the questions I ask our product teams all the time. Like, well, what are we doing? The way I advise customers is like, listen, you're migrating. A lot of times it's like with why it depends. I'll kind of like give you the battlefield. A lot of times customers come to us and they're migrating. They're not in the cloud, they're on premises, and they need to migrate to the cloud. They need to sunset legacy systems, and they need to keep the lights on while they're doing this. The last thing that I want to do to a customer like that is introduce, hey, we're going to retrain your whole team on how to do declarative. On top of migrating to the cloud, on top of sunsetting your systems, we're going to retrain them. And oh, by the way, we're going to redo all your data models, and we're going to completely refactor all of your code. It's way too much change management all at once. Like, I don't advise it. It's way too much change all at once. If something breaks, you have no way to track down who caused it, where did it happen, and what part of the refactoring did it go wrong. I think most customers should take a phased approach. So if you're migrating, don't bite off more than you can chew. You should definitely check out what the capacity of your team is, and don't change too much at once. A lot of customers, the options that you have right in front of you when let's say we have 3 customers. One is not in the cloud and they're migrating to the cloud. One is in the cloud, but they're on, let's say, cloud native services or another competitor service, and they don't like it and they want to come to Databricks. And then let's just say it's a brand new, net new greenfield. We're going to fresh build everything. The customers who's migrating, you have 3 options. You're going to migrate to the cloud. You can lift and shift, and you can pray that your costs aren't going to explode. So for that type of customer, I would suggest, and you're upgrading your enterprise data warehouse, you should definitely leverage, store procedures and the way you did things if you want to do a lift and shift. I want to clarify something. I don't believe in lift and shifts. I'm just saying these are your options. I think lift and shift is the most risky of all of them, just because the primary factor is a lot of your code for organizations that are migrating. A lot of that code that was developed by probably consultants over the past 10, 20 years. And to say it's probably not efficient is, being very delicate about it. And when you lift and shift all those sins of the past or the tech debt into the cloud, it gets really expensive. But I don't want to belabor that point. That's just an option. You can lift and shift. For those customers, stored procedures, SQL scripting, if you're coming from a SQL warehouse, it's the native way to do things on Databricks. That's a great option. Now, if you want to refactor your code, that's when customers start looking at declarative pipelines. A way to really scale it out is we have a project called DLT Meta, which allows you to if you scrub the metadata from your legacy systems, you can use the metadata-driven framework to push it all into declarative pipelines, and it'll build out what we call like bronze to silver for you, like automatically. And that's a way to kind of like modernize in the cloud. Kind of an in-between way between like fully remodernizing and lift and shift is what I like to call minimal viable refactoring, where you find the costliest tech debt in the stack that needs to be refactored, and you rewrite just those pieces, but you keep the core SQL logic and SQL like in the procedures. But like an example of this in procedures on-prem, super common practice is kill and fill. With your ETL, you truncate the table, you load the new table in, and you make it active, like super common. In the cloud, this is ridiculously expensive because it's multiple operations and you're paying every time you do the operation. In the cloud, we say just do create a replace table because it just stubs a new version of the Delta table. And then when we do Delta cleanup, it'll clean up those old versions. Eventually, you don't have to worry about it. And it's much cleaner and much more efficient to do it this way because you're not wasting cloud compute every time you go kill and fill a table. So like there are low-hanging fruit for minimum viable refactoring that I highly advise, and you can mix mode that. That's not full declarative pipelines rebuild, but it's kind of like an in-between lift and shift and in-between rebuild, which a lot of customers appreciate. Keeping the core logic in the original SQL syntax reduces the risk significantly. So that's like when you're a customer migrating from on-prem. Then if you're a customer coming from another cloud product, typically if you did a lift and shift the first time you went to the cloud, now you know why you don't do a lift and shift because of what's happened, the situation you got yourself in, right? And now you're like, well, maybe a lift and shift wasn't such a great idea. And maybe the vendors we chose originally, cloud native or kind of like their own data cloud type thing, wasn't really the best decision. And now they're like, well, how do I fix this? And a lot of times we're not going to lift and shift from that solution, right? Because it's still got the sins of the past in it. In those situations, I would kind of advise, let's kind of go more towards the minimum viable refactoring, inefficiencies that they have in that previous stack that we can maybe pluck some low-hanging fruit for. Maybe we can make it more efficient. Sometimes our compute engine just makes it more efficient underneath the covers with like a couple weird tricks. But if you have capacity, go to declarative pipelines to kind of do that. A lot of times, a lot of the efficiencies are in declarative pipelines. And when you do that one-time debt repayment, it kind of makes things run faster. If you're building brand new in the cloud, I'd highly advise taking the time to train up, upskill your team on these declarative frameworks. I think you don't want to build legacy tech greenfield. Like that's just something I would advise if you have the capacity. Plus, at this point, building net new, you can leverage AI to write most of the code. And so you just have to tell it which to use. I would just use declarative pipelines. So those are kind of like the ways and what to use where. Just I would be super conscious of the risk and debt repayment, technical debt repayment, and how much you can afford to repay to keep moving forward. A lot of times if you take on too much debt repayment in the migration, it'll take too long to get business value and the business will get fatigued, migration fatigued. And that's not going to help your case at all, right? So it's kind of like a balance of how much change in debt can we logically repay in the migration process before fatigue sets in and people start complaining about the migration. It's a very delicate game. That's why it depends. There's not one clean, clear answer. My favorite approach right now is to, when we have legacy involved, and a lot of companies have AI priorities, it's like we have to do AI. I have to do it this year, and it's August, and we don't have anything. Can you help me? I can't wait a year for a migration. In that situation, I highly advise, what's great about Databricks is we give you tons of options, right? I just talked about data ingestion. We have just talked about ETL. I didn't even talk about data ingestion, which we have Lakeflow Connect. And then there's federation. So you don't need to move the data. We don't need to wait for the migration. How about we just federate to the system where it exists today, the legacy system where it exists today? A lot of times these legacy systems can't take AI. AI has too much, uh, uh, it uses too much capacity on these legacy systems. And a lot of times legacy systems, they're being redlined. Like they're already out of capacity and they just can't take it. So a lot of times what we do is we federate and then we materialize a cloud copy for Databricks, and then we have AI use that. Show the business that you can get value out of AI first. Let's federate to the data where it sits, kind of prove the value out first. How about you treat migration as an optimization later? After we've proven we did AI this year, like we got to do AI in 25, let's do it. Let's use federation, show the business we can get value out of AI. And then when the business leaders come around and say, well, does it have to be this expensive? No, let's invest in an optimization and migrate our ingestion and our transformation over to Lakeflow Connect and Lakeflow pipelines.
Yeah. Yeah,
and now you have the business asking you to get it done, right? That's, I think, a better position as like a technical leader for you to be in. You want the business to come to you and be like, we need to migrate because we're getting so much value, but the cost is too high. We need to optimize our ROI. It's like, great, we can do that. We need you to invest in this migration of our ingestion and our transformations into modern, Databricks. If you've chosen us for that, I highly advise you do it. We do great with ETL, kind of like we set world records. But I highly advise that methodology, using federation first, prove out the value with AI, and then kind of look at to optimize with the migration. I think the business will be a lot happier. And if you have goals to do AI this year, it gets the job done. And then it entices the business to reinvest in the platform, because you don't want to say, we'll give you AI, but you have to wait a year and a half for our migration to finish. Who wants to do that?
Yeah, and federation does not only bring you like possibility to use your legacy data, or your legacy database in Databricks, but you also have the possibility to bring governance as well. For like the past few years, like I'm talking about SQL scripting, store procedures, recursive cities. This is mainly to help you reduce the friction when doing this migration. I remember like a few years ago, we were saying that data analysts will never do AI, or this is something they won't be able to use. And I've noticed the last couple months, we brought a lot of features that democratize access to AI to almost everyone, from business users to data analysts. I won't be talking about data scientists and data engineers because they have those technical knowledge to leverage AI. But what are your
Yeah. I think Databricks is working overtime to bring AI to the every person. We have AI query and a bunch of AI query for like anything. It kind of lets you plug and play. And then there are a bunch of stock AI functions now, as well as we just released in preview AI document parse. And I don't really like the name because it does PDF and images. You can read the text off of images, which is fantastic. A lot of unstructured data exists in these formats. What I'm finding is all the rage now is these SQL analysts are using AI query, these other AI functions and AI document parse to find value out of unstructured data or to leverage AI right in their queries, right in their analysis. And they're just using a function, and it's super easy and straightforward for them to use. And I am also seeing right now, a lot of times, like companies get a batch of docs in like overnight or hourly, and then they have to do some type of processing on them. What I'm seeing is that they're leveraging Lakeflow jobs with AI query in our serverless SQL warehouse to get super efficient document processing pipelines. Basically, serverless SQL warehouse spins up and spins down. It has all the functions and it can handle the throughput of these AI queries. And you can batch process a ton of documents in a job like really, really fast and efficiently. And then you can even do intelligence by wrapping AI query around AI document parse. You can actually build intelligence on top of unstructured data. And I'm seeing this as like an emerging pattern across the industries, is leveraging the document parsing with AI query to basically ask questions of documents live, or in a job, process unstructured data super fast. Like you used to have to load a bunch of libraries, and it was very complicated in SQL to do this. Now it's two functions that you have to put together. So that's what I think we're bringing AI to the every analyst. And even in Genie, you can teach Genie to use these AI functions or a custom function.
Okay.
And this is why I say we're going towards the every user can use AI ML. It's not, you don't even know how to use a function. Genie can just use the function in line and give you a forecast. And even in AI BI, you can do a forecast with a couple clicks. So I think we're bridging the gap between the every user and AI with function and these capabilities. It's fantastic.
That's amazing. Thank you so much, Franco, for your insights. It's always a pleasure to have you. See you soon, my friend.
Yusuf, thank you for your time. Good luck out there.
Thank you.